The red, green, and blue concept that happens inside of our cones is really important because it works along a basic light principle called additive color mixing. You are probably already aware of red, green, and blue being the three primary colors in all of your digital imaging classes. The reason for that is not only that they are the three colors we can see with our eyes, it's also that when I add them together, I can create all of the other colors. To simulate that, here in Photoshop, I've put a black background on my screen, and black has a color value of 0. I have my red dot, my green dot, and my blue dot. As I move them together, you'll see that when they overlap, I start to make these secondary colors. Here's magenta, here's cyan, and there's yellow. In the middle here, there's white. White has a value of 1 because it's all the other colors mixed together. That's how additive color mixing works, and this is how every single program out there is going to mix colors. It's also how light works in the real world. In the real world, pure white light is a mix of all of the colors, and then as it starts to fragment out, it becomes all of these secondary colors. So I know all three of my circles are really sharp. Let's see if I can take them and blur them a little bit. That might be too much blur. We'll try that though. Then I will repeat that for my other layers. And now you should be able to see that in here, in addition to just red, yellow, and green, here I've got this nice orange color, there's that yellow-green. In here I've got all of the violets and the indigos you could hope for. And again, as all of the colors overlap, that becomes white. At this point, I'm only dealing with pure tones. When I move into my color mixer, right now in Photoshop, I'm dealing with their traditional color mixer, but this chart right here is nice because it shows me my RGB values here, and then on this side, it gives me this chart. On this end, what I'm doing is I am changing my saturation, which goes from white to color. So that's saturation. And on this end, I am going between color and black, which is value. That'll actually be across this way, color to black, black to color. So value is a scale between color and black. Saturation is between white and color. Your hue is over here. So when you hear the term HSV, that's hue, saturation, value. We refer to this as three-dimensional color space. So I will write those terms out here. We'll start with hue, which is RGB. Then we've got saturation, and saturation goes between white and color, and then we've got value, which goes between black and color. The other important color mixing principle that we all need to be aware of as digital artists is the concept that black is the same thing as saying 0, which is the same thing as saying off. White is the same thing as saying 1, which is the same thing as saying on. And that's going to help us as we move through all of our color spaces in the digital world. So I hope you've learned a lot in this presentation about color, and pretty soon we'll get started in Maya working with three-dimensional light simulation.